Okay, welcome to another masterclass series of Ask the Building Expert. This is Lance Luke and Martin Pea. And guess what? You guys have your passports because we're traveling out of Honolulu, Hawaii, and we're going to Paris, France, and mainly to check out the Eiffel Tower. So that's the talk today. We're talking about the engineering marvel and the battle against corrosion. So let me advance some of these slides here. So we're presenting this webinar by Construction Management Inspection, which is a Honolulu-based construction management company. The reason why I was in Paris was I was actually on vacation with my wife. And, one of the highlights of going to Paris is checking out the Eiffel Tower, and there's a Louvre Museum and some other interesting things. The river, um, Seine River. It's interesting. The Seine River, like I was telling my wife, okay, why don't we ride one of those tour boats on the Seine River? And she goes, it's not the Seine River, it's the Seine River. And then when you talk to the French people that live over there, they pronounce it Seine. So, parlez-vous français? I actually took 13 years of French, but I couldn't speak to anybody there because they had a thick accent and I couldn't understand what they were saying. But the Eiffel Tower is about 133 years old. And of course, I went there as a tourist. So while I'm looking at the Eiffel Tower and figuring out how they maintain it and if they have rust and all that, my wife's taking pictures as a tourist. So it's kind of a little different. And speaking of rust, if you're from Hawaii, there's a Aloha Stadium that has a rust issue, corrosion issue also. And the Aloha Stadium didn't last. The Eiffel Tower, if it was not maintained correctly, it probably wouldn't last either. And let me give you some information before I continue the slides. The Eiffel Tower is the height of the Eiffel Tower is 1,083 feet tall. And in comparison, that's a little lower than the Empire State Building. And so that gives you a perspective. You can see it, it's the tallest structure in Paris, or the second tallest. Kind of everywhere you go, if you look in the direction, you can kind of see the structure. And if you look at one of the sides, it looks like the letter A, and so it's pretty strong. And how many floors do you think the Eiffel Tower has? Anybody can guess? It actually has only 3 floors. It's so high, but there's only 3 floors. There's first from the first floor to the second floor, you got to walk up 300 steps, and then the second floor to the third floor, you got to walk up 300 steps. If you want to walk, they got about between 5 to 7 elevators. On the second floor, there's actually a restaurant, and the reason why there's only 3 floors because the top floor is the third floor, is the top floor, because if you look at the second floor to the top, there's really no a building per se, no enclosed building. It's basically all steel frame. And interesting fun fact here that during times of a lot of sun, a lot of heat and all that, the due to thermal expansion, it's been said that the metal, especially at the top, could actually expand like up to 6 to 7 inches. So you have like a building that has a variation between zero, as it's constructed, to maybe 6 to 7 inches larger. And that's an interesting thing. So the structure is kind of always moving depending on the weather. And who owns the Eiffel Tower? The city of Paris owns the Eiffel Tower. And here's something a lot of people don't know. When the Eiffel Tower was first built, it was only built um, to last 20 years. And after year 20, they were going to demolish it and take it apart. But over time, I guess the city of France decided that to make it a monument for everybody, and they need to preserve it. So let's continue. The introduction of the Eiffel Tower, it was built in 1889. I think, Martin, were you around that time? 1889?
Not quite yet.
Oh, okay. Just checking. Eiffel Tower was built in 1889 by Gustave Eiffel for the World's Fair in Paris. So that's how come the tower's named Eiffel Tower, because it was built by the guy named Eiffel. And it was built for the World's Fair. And after 20 years, they're going to take it down. Okay, so um, it was the tallest man-made structure in the world for over 40 years. And that's probably how come it became so famous. And construction and building wise, it was made from 7,300 tons of puddled iron and assembled with 2.5 million rivets. Now, puddled iron is a term that they use, but it's basically wrought iron. So you have these molds and you pour the iron and steel, and then when it cools off, it becomes pieces of iron and steel. And then you all know what the rivets are. So there's a lot of different components that go into this structure here. And it was the first major project to use modular prefabricated metal parts at this scale. So they didn't just bring in pieces of steel and weld all the pieces. Okay, they kind of built large sections of the structure and they trucked it to the site and they set it up. So it got set up by historical accounts in 2.5 years. And that's pretty fast. Okay, that's a very fast construction project. And it's a global symbol of innovation in engineering and construction. By today's standard, it's still a marvel. In fact, when I was there looking at it, I was trying to figure out how in the world did they come up with this design and everything. The structure remains standing due to ongoing inspection, corrosion control, and repainting. Now, in any kind of building, especially one made out of steel and iron, if you don't maintain it, it's just going to corrode and eventually collapse. So, by the way, I also went to another Eiffel Tower in Las Vegas, and um, it looks like a way smaller replica of the Paris Eiffel Tower. And is interesting because the one in Las Vegas, right at the top, there's a restaurant, Eiffel Tower restaurant that I ate there, and it's part of the Paris Hotel grounds. Maybe I'll tell you a little bit about my adventures at the Paris Hotel in Las Vegas if we have more time at the end. So we're moving along and we're looking at the structural journey. The tower is built from wrought iron, protected by paint. Now, if they didn't paint the building, it probably would have collapsed already by now. The iron is very strong, but it's not corrosion resistant, especially in wet or polluted environments. So if you take a piece of steel and you left it out, exposed to the weather, eventually it's going to start rusting. And then there's a lattice design, makes the structure less resistant to wind, but it allows water to collect in the joints. So anytime you have like a flat surface or a surface where if it rains, water can sit there, collect on it, that's not a very good condition, but you can't help it because every building has flat areas. There's also over 18,000 metal parts, and they're connected by millions of rivets, creating many vulnerable points. Now, if you look at what a rivet is, it's like, looks like a button, and it's a button with like a stem, like looks like a mushroom, if you look at it, and they weld all these rivets in place. It's used in lieu of like a nail or a screw, basically. But what happens in a situation where you have all these rivets and like it gets wet, it rains, or there's a lot of moisture? So the area where the top of the rivet connects with the main metal, okay, you could have an area where water could be sitting there. So can you imagine millions of areas are collecting water and just having water sit there? Eventually, the water is going to start rusting out the metal. Okay, so the structure faces constant exposure to rain, wind, humidity, and pollution. Believe it or not, there is pollution in Paris, just like there is pollution in a lot of major cities, like Barcelona, Spain. You know, there's pollution. Lisbon, Portugal. I mean, almost everywhere you go, there's pollution. London, England. I've been to all these places, and some of them, you know, on a nice sunny day, it's nice, but then other times you tell because of all the industrial and too many cars, right, polluting the environment. Let's talk about corrosion in the Eiffel Tower, causes of impact. So what's the causes of corrosion? Like I mentioned, water, humidity, humidity from the Seine River and the Paris climate. So you may say, well, what's the deal with the humidity? Anytime you have like water, ocean water, a river, a stream, there's evaporation of the surface of the water, and that causes humidity. Also, pollutants like sulfur dioxide, it creates acid rain. You have all these cars, exhaust fumes, and industrial factories blowing their caustic smoke in the air. The other thing is moisture traps in the joints and rivet overlaps in the structure. The impact, of course, corrosion weakens the joints, plates, and lower legs of the tower. Rust leads to material loss, cracking, and structural stress. And then you have the aesthetic damage from rust stains and peeling paint. Now, analogy would be you're driving around your car. Your car is made out of metal. Most cars are made out of metal. I know a lot are made out of fiberglass and plastic now, but let's say you're driving around a metal car and then there's some scrapes on the paint. Okay, the paint on your car is pretty thick, but all it takes is like a scrape or whatever, and you have the bare metal is exposed. So the bare metal is going to start rusting because the metal doesn't have any protection. It doesn't have any paint to cover it up. So that's why if you see old cars driving around and you can see the rust and all that, that's just what's happening, especially in a coastal environment where we're surrounded by ocean water, seawater, the trade winds blow the salt air and it gets on everything. So that's why if you um, stay at hotels that are beachfront, or you stay in an Airbnb, or you go to someone's house that's on the beach, if you look at their windows, you can see it's not that clean because that's all the salt building up, from the wind and the rain. History of corrosion in the tower. The tower is repainted every 7 to 15 years to protect the iron from rust. So fortunately, the um, the builder specified in the maintenance documents that you have to repaint, often. But what happens when you keep painting? So since 1889, the tower has received over 19 coats of paint in total, like once every 7 years. So the builder specified that this guy was pretty smart. He knew that the metal wasn't going to last, so he wrote in the maintenance specs, you have to paint every 7 years. So I think it's about a 20-year cycle now, but it's starting all over because the last time they had this big improvement, which was a major improvement, they scraped the majority of the paint off to bare metal. And because if you keep applying paint, a lot of coats of paint, it adds to the weight. So the other issue is too much weight, and then early on, nobody knew that the paint they used had lead in it, and it was since proven to be hazardous. So they wanted to remove and strip the lead paint off to make it safer. So early paints used lead-based coatings that were strong, but very hazardous. So you have a health environment issue as well as a corrosion environment. And then the paint that was later replaced with better paint, safer paint, zinc-rich primers, epoxy intermediates, and polyurethane top coats. So we're trying to get away from the lead paint, make it safer. And then when the maintenance crews were painting, they have to target the horizontal surfaces, the riveted joints, and lower base areas that were most prone to corrosion. So on this big structure, the majority of the corrosion was happening on the lower base areas, not necessarily at the top. Okay. Also, there's latest and greatest inspection and maintenance techniques. Now you have a lot of camera imaging and all that. In the old days, it's basically look at it and figure out what's going on. And now we have these non-destructive inspections, the NDT, visual checks for blistering paint, rust stains, cracking, and then various tools that are used, ultrasound, infrared cameras, moisture meters, thermography cameras, and all that. So the technology has really gotten more advanced, which is good because now we got a clear idea what's going on. Also, the use of drones. Before, in the old days, somebody would have to go climb up and hang off the building and do their checks, use a screwdriver, some other instrument to scrape paint and see what the condition is. So Um, Now we can use drones to capture high resolution images of the joints, beams, upper sections where it's hard to get to, and then improve safety and reduce costs of tower-wide inspections. So instead of hiring inspectors, humans to go up and take a look, the drones are much faster and much safer. And then destructive methods when needed. So sounding. So you get an instrument, solid instrument like a hammer or uh, a screwdriver or something, and then you tap certain areas to locate hidden hollow or rusted areas. And this is the same technique used for investigation of spalling, concrete spalling. So you're getting a hammer or some kind of instrument and you're tapping the metal or you're tapping concrete, and if you hear a hollow sound, then that's a void, and it could indicate rusted areas on the interior where you necessarily don't see it on the surface, right? Also, limited cutting removal is done only when major internal corrosion is suspected. So where, because of the historic nature of the building, they don't want to be cutting pieces out. And once you cut a piece out, you weaken it and you're basically destroying part of the building. And when you have to cut sections out, that's called destructive testing. So the destructive testing is limited. Cutting into iron risks structural damage and aesthetic issues. It's expensive, labor intensive, and used as a last resort. The other thing is, if you keep having a lot of cuts in a structural member, even if you weld a thicker piece there, it may not be as structurally sound. So for purposes of investigation, I just want to explain that there's two types of testing. There's a what's considered, or the terminology is non-destructive tests and destructive tests. Non-destructive would be um, a visual test or using infrared cameras or thermography cameras, drones and all that, where you're not um, doing any damage. Okay. And destructive testing is cutting up the building, pieces of the building, or as part of your investigation. Now, when we talk about sounding, like tapping, it could be non-destructive if you're not damaging anything. But let's say you don't see rust, and you use a hammer and you tap it, and all of a sudden now you create a hole where there was no hole before, and there's a void there because of rust, right? So that's why it's called destructive testing. And you're not purposely trying to cause damage to the building. It's just that you can't help it because it was so rusty. Protective coating and paints. Paint is the main protection that you use because it prevents oxygen and water from getting into the iron. So without it, corrosion starts quickly. All you need is a pinhole in the paint, and air and water can get in, and then it could start corroding the iron. Over 60 tons of paint was used per repaint cycle. So every time the entire structure is painted, we're talking about 60 tons of paint that's used. That's like a lot of paint, but it needs to be done. And then I don't want to get too technical, but there's a 3-layer paint system. You have once the uh, corrosion is mitigated and there's no corrosion anymore on the metal, and then you use primer, and then you have a epoxy intermediate coat, which adds thickness, and then after that You have a polyurethane top coat. It blocks UV pollution and weathering from the elements. Okay, so it's typical. The idea is, let's say you're painting your house. You sand it, and your house is made out of wood. You're going to apply a primer, and then you may apply either one or two coats of finished paint. Okay. As I mentioned before, the old paint used lead, which is now banned. Safer paints are required by law. And then, believe it or not, painting takes 12 to 18 months. And they're not going up on the tower and using like a spray gun, which would have been a lot faster. Spray painting is way faster than painting by hand, right? So the idea is that's why the painting takes like a year and a half, because the workers are painting by hand using brushes so they can get into every nook and cranny. Because if any like half an inch area is missed, that's where the corrosion can start. Water can enter. Current and future repair plans. You have routine maintenance, which includes scheduled painting and surface inspections, cleaning and touch-ups on high-risk sections. Common repair zones, of course, is riveted joints, the lower legs, and the horizontal beam, which is common in any kind of steel frame structure that's exposed. There's a lot of buildings that are actually made out of steel, but like in New York, for instance, in the old days, but then they use steel and they covered the steel with concrete or some other kind of material. So you're not looking at just a steel frame building. In the future, there may be few other space age materials, nano coating that repel moisture and dirt, and then they're in the process of inventing or looking at self-healing paint. So when you apply the paint on, if there's small cracks, the paint basically is said to seal itself or seal the cracks and all that automatically. And then the painting industry is always trying to come up with sustainable improvements, new paint, ecology, environmental friendly paints, low VOC, volatile organic compound, so it's not hazardous to your health, reduce waste and safer materials for workers. Case studies, we have the Statue of Liberty, which is actually a copper skin with a um, over iron frame, and once moisture gets in, there's corrosion starting. So the Statue of Liberty required major internal replacement in the 1980s. And in Hawaii, we got a lot of concrete spalling, and there's reinforced steel, rebar, and that gets corroded. But the Aloha Stadium was made out of steel, and of course, it just got too corroded because the engineer said the minor rust will be a protective coating over the steel. And people believed that. And it was even in the warranty paperwork, but it never happened to be true. That's why the Aloha Stadium had to be shut down, and it's going to be demolished soon because it's unsafe. So the conclusion that I have is, let's pay attention to any kind of corrosion, rust, and you want to abate, you want to mitigate, and not have the rust continue, because once there's a speck of rust, it's going to get a lot worse. So it's better to deal with it now and pay the price than ignore it, and then the cost to repair it is going to be a lot greater. So that's kind of the rundown in a nutshell. Let me before I get to the Q&A, I'm going to just cover some things. What you missed, well, some of you, and by the way, I forgot to mention, appreciate you guys attending on our Zoom platform. Also, those of you who are on Facebook, LinkedIn, and YouTube, we're restreaming live. So those of you who are listening now, that's good. If you're not, you can watch the replay. And if you have any comments or questions, just post it, and either we'll get to it now or we'll get to it soon after. But we promise to respond to all of your questions. Oh, so what you missed is we didn't miss, but you guys may have. We've given, I think, to date about 105 different webinars, master classes, and it's all on our website, and you're free to watch it. You don't need a Netflix account. You don't have to pay anything. It's all there. You just select which ones you want to watch, and you can watch it for free. It's just loaded with information. And what's coming up? We have a lot of different webinars, good topics coming up, and go to our website, take a look. And you may ask, well, what's your website? The domain name is askbuildingexpert.now.site. You go to that website, you can find other expert websites on a lot of different things: painting, waterproofing, contractor licensing in Hawaii, Lahaina fire, asphalt, almost every kind of building component we have a website for. If you can't find that, we have a national building expert blog filled with a lot of information, and we update our website every day. And then here's a short list of webinar topics: leaks, drainage, mold in buildings, rebuilding your home after a wildfire, fixing building foundation problems. We have a whole bunch of things. And then we have books on our website that you can check out. I think we have about 68 books that pertain to building, construction, real estate, condo, safety, and that kind of thing. And then that gets us to the Q&A. So Martin has been very quiet, so now I'll let him talk. So Martin, let's see, any questions come up?
Yes, Lance. We've had a few questions that have come in prior to this webinar and during it. So let me give you a couple of them here that may be of interest to the audience as well. The first one here is, are there any modern paint or coating systems that can completely prevent corrosion long term? Or will all metal structures eventually need full repainting cycles?
Well, the answer to that is I haven't found really any that, well, a lot of manufacturers say that it can prevent corrosion long term, but you got to look at the warranty, and then there's fine print. If there's any nicks, scratches, damages, or um, acts of God kind of thing, hurricane, tornado, and all that, their product is not warranted. Okay, and then any kind of metal structures, if it's just metal painted, not covered by concrete or any kind of other material, eventually you're going to need repainting. So there's no product, even like um, the paint they use for military or rockets or anything like that, going into space. I don't think there's any kind of protective coating that's like lifetime guarantee or lifetime warranty. So just even if they offer that, in my opinion, it's not going to last. You still need to do some kind of maintenance or at least inspection to check things out. It's not like set it and forget it kind of thing. So yeah, that's interesting. I mean, the scientists are continually working on different coating, waterproofing, paint products to make it last a long time. And there's kind of a race. So whoever can come up with the best product, space-age product is, people are going to want to buy that. It's going to be expensive, but it may be worth it.
Okay, thank you, Lance.
Sure.
The next one here is an interesting one. Has any part of the Eiffel Tower ever needed to be replaced due to corrosion? Or has it actually just been repainting and touch-up since what is it, 1889 when they first put it up?
Yeah, okay, so historical data, there has not been any major steel replacement. There've been minor areas where they have to, touch up, but nothing on a global scale. So basically, it's the entire job of maintenance is basically repainting and then touching up. So you do a whole uh, structure repainting, and then during the period from up to 7 years, then you kind of do inspections and touch up as needed until your next cycle. So every 7 years, if you compare it with, say, Disneyland, they're painting every day. So there's a difference, right? So, um, but then Disneyland, um, you have a lot of wood as opposed to a lot of steel, but um, they do have their own maintenance program.
Yeah, well, that's good, and it's kind of a tribute to the maintenance schedule and the maintenance program that it's continued to work. So that's why those things, I guess, are important when you're trying to maintain historic places. Yeah,
Right.
yeah. Okay. The next question that's come in is why did they choose iron instead of another material? And if the tower were built today, would they use something else?
Oh, that's interesting. The reason why iron was chosen was because the designer and builder decided that that was the material to use back then. And in in the late 1800s, it was never thought to use any kind of material such as wood. You back then you don't use wood structures to build that high. It was like impossible. Even today, there's no wood structure to go up 1,000 feet like that. Although they're looking at it now, um, so that was out, and then um, you the technology wasn't there to figure out how to build a structure that high in that with that kind of design using reinforced concrete or any other kind of material. Basically, it was either steel, wood, or concrete. And so you go back and, I mean, if you were the designer and builder, you have those three um, mediums to use, like wood's out, concrete's out. If you go back to um, Roman times or other civilizations, they use mud. You couldn't build with mud going that high. And let's say you follow the Roman or Greek architecture and all that. Well, you could build several stories high, like the Colosseum, but you can't go 1,000 feet high using limestone and things like that. Maybe they should have consulted the Egyptian, but even the pyramids weren't that high. So um, yeah, that was basically, it was kind of like if that guy, Mr. Eiffel, was here today and we asked him, he would probably say it's a no-brainer. That's the only material that we could have used. We couldn't have used anything else, right? So that's probably what happened.
Yeah, sounds reasonable. That's all that was available at the time. Yeah, so
Right,
I think when, like, it was the highest one, it said on the, on your slide, for about 40 years, yeah. And that 40
right.
years takes you into like the 30s. So that's Rockefeller kind of time where they're building now the cement towers and the reinforced stuff. So it was kind of like, seems like it was, had to wait until we entered the age of the high-rise buildings that they do, then and now, yeah. So yeah,
Yeah, I don't think the technology was there at that time for any
yeah,
kind of other building material than, the steel.
yeah. And had to wait until that time came, yeah.
Yeah.
Okay, I think I get one more question here. And is with all the corrosion risk and maintenance work, has there ever been a real concern that the tower might become unsafe?
Interesting question. The answer is yes, the government is always concerned about the safety factor because millions of people, tourists, go check it out. And so that's why they spend a lot of money in the repair and maintenance because they can't afford to have part of the building fall down or accident or something like that. So they're always concerned. In fact, I think that's top of mind that if they don't maintain it, then something, may happen. In fact, just going back to the original specs that say you got to paint every 7 years, well, why did the guy even recommend that? Right? He recommended that because he knew that if it wasn't done and there's lack of maintenance, then eventually, something's going to happen. And the guy was pretty smart because although the idea was they're going to tear the structure down in 20 years, he still made the painting every 7 years recommendation. He could have said, it's only going to be there 20 years. I don't think it's going to collapse if you don't repaint. But he was smart enough to know, right? So even even by today's standards, the repainting every 7 years is really aggressive because I don't even see modern condominiums having the 7-year paint schedule, with the exception of maybe high-rise condos or other buildings that are near the ocean or on beachfront. They may need to paint every 7 or 8 years just because of the environmental factors and salt air and all that stuff. So um,
Yeah.
that's a,
Oh, interesting. Yeah, yeah. I was just had a couple of thoughts on this. Is looks like Mr. Eiffel wanted to make sure his tower was around long enough so people would, would still be able to see it and visit it and do all that stuff. So that's an interesting, I guess, uh, prep on the part of Mr. Eiffel to make sure his projects were around long after he was there. So interesting. Good. I had a
yeah, I
question.
mean,
We don't have any more that I've seen come through. You
okay,
mentioned
okay.
something
Well,
about
it's interesting that someone would design and build something with the intention that it's going to be taken down after 20 years.
right.
So I'm not, I mean, if I was a builder designer, um, I would say, okay, if you guys don't want it, um, we'll take it down and we'll, you know, take it apart piece by piece and we'll rebuild it somewhere else,
Mm.
right? Because to have a steel structure like that, um, that's going to be taken down in 20 years, that's kind of like very expensive and overkill, to spend that amount of money in building something that's going to be demolished after a 20-year time span. And look at today, it's still standing. Um, I want to mention that if the audience has any additional questions, you can ask later, but there's a website called toureiffel.paris. Toureiffel.paris, and you can go there and there's more history, and you can even see what's coming up in the future. And I think, well, when you go to the website, the name um, on the uh, first page is called La Tour Eiffel, but the website is just toureiffel.paris. So I've been on that website. It's an interesting website. And I want to share a couple stories. When my wife, since we have time, Martin, you got any other comments or anything before I?
Oh, well, just you mentioned about what, 60 tons of paint to, to repaint it every year. So I was thinking, well, that's from an economic standpoint, that's a good contract for some business to provide all the paint that has to be used over the years for that thing. So it's I'm always looking at the cost of things. Yeah, so that's interesting. Uh,
Well, I tried to sell them paint, but they said they don't use that paint because it was from China and they're worried about the tariffs. So I
Yeah.
don't know what's
Okay. No,
happening
no,
on
no. So
that.
that was just my comment. I thought
Yeah.
it's interesting. When you look at all the materials need to repair the cost of those things. Yeah.
Well, let me share some, since we got, some time. I want to share some stories about when my wife and I went to Paris. My wife is an artist, painter. She likes to paint, so we go places like we go to Paris, and you look at the list of where places we want to go to, and the majority of the places on the list were art museum, right? Eiffel Tower was one, but then we had a lot of different. I mean, there's a whole bunch of different museums, and um, the most famous one is the Louvre, right? Which is huge, and one of the reasons why people go there is the most famous, or one of the most famous paintings called the Mona Lisa. So I'm like, okay, I'm excited to go there. So you wait in this long line. The lines are probably even longer now to get into the museum. And at that time, and probably even today, there's no, when you're waiting in line on the promenade before you enter the museum, it's open. So when the sun's shining, you're baking in the hot sun, getting a free suntan just to get into the museum. And so we get in, and we there's all these little sections and all that, but we're trying to make a beeline to go to the section um, that the Mona Lisa painting is in. So you probably gotta walk a mile, and then there's this long corridor, and I'm like, okay, we're gonna finally, gonna get in. We get in, and it's like this huge, huge hall, right? And it's packed, and everybody has their hands up with their phones trying to take a picture. And there's this little dinky painting of the Mona Lisa on the wall, right, the back wall, and it looked like a postage stamp because of the area that was so big. So I tried to bowl my way through to get almost to the front, and I think I was like 50 feet away, and I gave up already because um, there was too many people there. So I ended up taking, some photos, but because you're far away, you gotta kind of use your um, enlarge your focus feature, and then when you do that, it doesn't come as clear as you want to. But there were like a lot of guards there and all that, so it kind of reminded me like, wow, I had a better view of the Mona Lisa looking at an art book than I did in person at the museum. But it was one of those like, okay, I did go to the Louvre, I did see the Mona Lisa, and okay, well, check that off on the list. So I wasn't I wasn't that excited after that. Um, the other story I had was one one night I was hungry for pizza to eat pizza, so I walked down the avenue and I stopped in. There's so many restaurants in Paris, just like in Europe. There's all these restaurants, and they have indoor seating and they have outdoor seating. And the outdoor seating is just basically on a sidewalk. They have chairs and tables on the sidewalk. I've seen that in Venice and in Portugal and Barcelona and all that. So it's an interesting concept. So anyway, I didn't know. So I walk in and I ask, oh, I want to order a pizza. And the lady, she said, this this is Paris. This is France. We don't sell pizza here. Go to Italy if you want that. And I'm like, oh, kind of rude. And then I heard stories about the people in Paris. They don't like people from the United States. They don't like American citizens. I don't know for whatever reason. So um and then we went to another restaurant and it was like 15 minutes before they closed and they said, "Oh, we're closed already." So my wife says, "Gee, what kind of deal is this?" And I said, "Oh, I read these stories where they don't like Americans. They know we're Americans, and I don't know what happened or whatever. Maybe they got mad at us because we call it French fries or something. I don't know what the story is, but yeah, that was pretty interesting. And then you go to these restaurants, and when you want to use the restroom, it's like you got to walk down these stairs, and it's all the way in the basement. And most times it's free. Sometimes they give you this little coin, and you got to put the coin in and turn the crank and all that. So, but back to the Louvre, um, the Seine River. Actually, when we got there, there's so many bridges across, and I noticed that the river didn't look that clean. It was kind of polluted. I think they had to clean it out because they had the Olympics and stuff, but I think it's still like polluted. And there's all these tourists that buy these locks, and they put the lock on the bridge, the railing and all that. And I heard that the weight of all these locks are too great for the bridge. So they have to every once in a while go and cut off all the locks and throw it away, or I don't know what they do. So the last story I had is after the Louvre visit, somehow we bought all kind of stuff and I ran out of euros. So um I had like $100 bill US and I wanted to exchange it for euros. So there was this exchange place at the shopping center right next to the Louvre. So I go, okay, I'm gonna, exchange my US for euros. So I tell the lady, oh, here's $100 US. I want euros. And then she says, oh, hold on. And she was like calculating something. And she came back and said, I can give you 50 euros. And I look at my wife and said, my $100 just went down to $50, right? It was kind of a bad deal, but somehow the exchange rate, and then you're in a tourist area, so the exchange rate is even worse now. So I said, oh, no, thank you. And I took it back. I wasn't going to get ripped off, but I remember before we went on the trip, I went to the bank and um, I had $1,000 US money, and I said I want exchange for euros because I'm going to Europe. And they came back and said, okay, well, with the exchange rate, we can give you 700 euros. And I'm thinking, wow, this is like going backwards here. So I like to have cash. So everywhere I go, so when we go to Portugal, Barcelona like that, we always make sure we have euros, right, with us. But I learned that you want to use your credit card as much as possible, then you don't have to worry about having too many euros. But when you're on the street talking to the street vendors and buying souvenirs and stuff like that, you don't want to keep using your credit card. So that's when the euros come in handy. Plus that sometimes you can bargain, with them. Like I think when I was in Rome, I bought all these keychains and stuff, and I got a good deal. So plus that if they accept credit cards, sometimes there's a additional fee for processing. So yeah, so and then when I'm on cruise ships, and then some of the cruise ships, when you want to exchange your cash for euros or whatever the currency is, they charge a fee to do that too. So slowly your value of your money gets less and less. So anyway, that's my Paris stories. I think I got a oh yeah, I had another one. They got these restrooms right on the street, right on the sidewalk. And I never heard of that. So my wife says, "Oh, I gotta use the restroom." And I go, "Well, can you wait till we find a restaurant?" She goes, "Oh no, I don't think I can walk that far." So then we found one of these things, and you wait in line, and um, I didn't first time. So you go in there, and then I guess you got to wait for the green light. When someone's in there, there's a red light, and then turns green. When the person leaves, you got to wait a while. And I realized that it's like washing itself before the next person goes in. So I heard in Japan, there's like a whole bunch of them out but it's kind of strange that you're right out on the sidewalk, it's like, but no one can see because it's all, enclosed. In Japan, they got the uh, glass where you can see right through, then you go in and then the glass gets clouded or whatever. So anyway, I know it's right kind of ran out of time here. So appreciate everybody for attending and tuning in, although this subject was not anything to do with Hawaii or United States. But it's fun to do these little things, especially because I personally visited the site myself, and it's interesting when my wife knows me already. I'm over there taking a whole bunch of pictures, and it's not, for a tourist magazine. It's for my use. I'm actually looking for rust and concrete spalling and all that, and all these tourists are taking selfies and stuff. So little kind of different concept, but please tune in to our next webinar. And like I mentioned before, if you guys have any questions on anything that comes up with this subject on corrosion or anything like that, feel free to post, and we'll promise to answer your posts and get back to you. Also, you can reach us through our website. So on behalf of Martin and I, and Ask the Building Expert webinar series, master classes, thank you for attending, and we'll see you again. Aloha and mahalo.